let us discuss in this video. This is a very simple question, but also it's a simple question with a complicated answer. It took Isaac Newton to answer this question. So the question is, if I have a graph, how do I compute the slope of the tangent line at a given point? For example, if I give you the graph of the function f of x equals x to the power 3, the cube of x, and I want to find the slope of the tangent line at x equals 1. So how do I do? What I want, this is the tangent line, so I want the slope of this tangent. Okay. So the idea here is to go by approximation. So let me repeat here the plot a little bigger. Okay, and let's say that we want to work on this point. This is x equals 1. Okay, so what we are going to do, we are going to look at other points and see approximations of that tangent. So instead of taking the tangent at the point, let me take the line that crosses through these 2 points. There you go. So this one is not tangent. This is a second line that passes through 1, f of 1, and 2, f of 2. So f of 1 is equal to 1, f of 2 is equal to 8. Okay, so I can write it down. Okay. So how do I compute the slope of this line? So the slope is going to be the value of f at 2 minus the f of 1 divided by 2 minus 1. So this is the difference in height, what I have gained, divided by the distance I took. So this is 8 minus 1 divided by 1, so this is 7. Okay, so the slope of that second line is equal to 7. But now I could decide, well, why should I stop there? Let me repeat this idea. Instead of 2, let me pick x equals 1.5. Okay, and let me take the second line that passes through that point. Okay, so how do I compute that slope? Same idea. F of 1.5 minus f of 1 divided by 1.5 minus 1. So this is going to be 4.75. Okay, so we can zoom in here and using a different color, we can repeat the idea. Instead of 1.5, we can try 1.2. Okay, so so if this is the second line, okay. Notice that when I look from farther away, it's already looking quite tangent. We can see that it's still second, but it's getting there. You see the approximation, how it's working there? So minus 1 divided by 1.2 minus 1, and this is going to be, if you compute it, 3.64. Okay, and we can keep going. So I have done 2, then 1.5, 1.2. Let me do now 1.1, and let's try then. Well, actually, that's going to be too close. Let's jump a little forward and say 1.01, 1.001, 1.0001. Okay, you see that the idea is that if we get closer and these slopes somehow accumulate, then we have a good approximation. So then the slope, well, let me stop writing that. So f of 1.01 minus f of 1 divided by 1.01 minus 1. What I got was 3.0301. Okay, then we can keep repeating this. So now instead of 0.1, we have 0.001. Okay, and what I got was 3.003001. And then I can do 1.0001 minus f of 1 divided by 1.0001 minus 1. And what I got here is 3.0003001. So if you have to guess, what would be the value of the slope of the tangent line? So we got 7, 4.75, 3.64, 3.03, 3.003, 3.00030. So it looks like the slope of the tangent line at x equal 1 is 3. So that's our guess. Is equal to 3. Okay, so this was an approximation procedure, but we can write exactly the value, the exact slope is the limit as x tends to 1. Did you notice that all the values were closer and closer and closer to the original point? So we were taking values that were each time closer to x equal 1. So the limit, here my calligraphy is a little funny. This means limit, lim, but I write it in a funny way. So the limit as x tends to 1 of f of x minus f of 1 divided by x minus 1. Okay, so when this is the limit as x tends to 1 or as x approaches 1. Okay, either way we can say. We will get more in detail about limits in the next couple weeks. But for now, the idea is that we can find the slope of a tangent line using an approximation procedure that is called a limit procedure.